In today's video I am going to discuss about a very interesting problem that is known as Ramanujan paradox. That means I am trying to show that sum of natural numbers up to infinity will be equivalent to minus 1 by 12. Obviously it is apparent that it is absurd to think like this, but gradually we will see in today's video that it is actually possible. So we can start in this fashion. We need to find out the sum of this expression. So let us start like this. Suppose we are taking two expression. One is say S1, which can be written like this, and so on. Now if you observe this carefully, I can rewrite this expression in this way. Because I am putting bracket and taking minus common, this entire expression will look like this, and so on up to infinity. So practically it is nothing but S1 again. So from here we can say 2S1 is equals to 1, and that means S1 will be equal to half. This is the equation number 1. Now again let us define another quantity, say S2. Now how to define S2? Simply let us consider 1 minus 2 plus 3 minus 4 plus 5 minus 6 and so on. In this way we can carry on up to infinity. Now here if we want to find out S1 minus S2, then you can easily understand. You can perform this operation like this. Up to infinity you can carry on. For S1 already we have described what is S1 and also what is S2. 1 minus 2 plus 3 minus 4 plus 5 minus 6 and so on up to infinity we can consider. Now here just let us rearrange this structure term by term. That means first term is 1 in the first bracket, also first term is 1 in the second bracket. Similarly first term is second term is minus 1, second term is minus 2 in the second bracket. So let us arrange accordingly. So we can write in this fashion 1 minus 1, that is I am taking this one as well as this one. Then if we consider the pair for the second part, then it will be what? Minus 1 minus minus plus 2. In a similar manner we can also find out the third part, that is 1 as well as what? Minus 3. Similarly you can say next part will be what? Minus 1 plus 4. So in this way we can carry on up to infinity. Now here also you can see, if we consider this structure, then actually it looks like what? You can see, so S1 minus S2, actually it is nothing but this part will be 0, no doubt about that. 1 minus 2, then plus 3, next term will be minus 4 and so on. So we can write 1 minus 2 plus 3 minus 4 and so on. So actually this part is equivalent to what? 1 minus 2 plus 3 minus 4. In this way if you carry on, then actually as per our assumption, actually not, it is yes, obviously 1 minus 2 plus 3 minus 4, actually you can see from this particular expression this is equivalent to what? This is equivalent to the structure of S2. So we can write, for convenience we can take this one equation 2. So this part can be written as what? S2. So S1, this is equal to 2S2. Now, or in other words you can say S2 will be equal to S1 by 2, but already in equation 1 we have obtained the expression of S1. So S1 is what? Half. So S2 will be 1 by 4. Say this is equation number 3. So we have obtained S1 as well as S2. Now let us try to find out the difference between S2 as well as S. So say now performing S2 minus S, we get, now just observe the structure of S. S is the required sum and S2 is as per our assumption 1 minus 2 plus 3 minus 4 plus 5 minus 6 etc etc. So if we want to calculate this expression, then S2 minus S can be written as 1 minus 2 plus 3 minus 4 plus 5 minus 6 and so on, minus 1 plus 2 plus 3 plus 4 plus 5 plus 6 and so on. Now again we are going to arrange term by term. That means we are considering the first term for the first bracket, first term for the second bracket. That means it will be 1 minus 1. Then again you can consider minus 2, that is the second term of the first bracket. Also you can take minus 2 from the second bracket. That means second term of the second bracket. So first term of the second bracket as well as second term of the second bracket. Then 3 minus 3, then minus 4 plus 4. I hope you can clearly understand the odd position terms are getting 0. You can see 1 minus 1, 3 minus 3, all these parts will be 0. Similarly here you will get what? 5 minus 5. Moving on in this fashion, you can see the next term will be what? Minus 6 and minus 6. So I can write in this way, minus 6 and minus 6. So we can carry up to infinity in this fashion. But what does it mean? It means S2 minus S is equal to what? This part is 0, this part is 0, this part is also 0. So you can see minus 2 minus 2, that is minus 4. Here also it should be minus because here we have a minus sign. Minus 4 minus 4, that is minus 8. Then you can see minus 6 minus 6, that is minus 12. So minus 4, minus 8, minus 12 and so on. In this way you can continue. So S2 minus S, this can be written as, after taking minus 4 common, 1 plus 2 plus 3 and so on. It will carry up to infinity. But practically S2 minus S, if this is equal to this expression, remember this part is what? This part is our actual structure S, whose sum is to be determined. So actually you can write this is equal to what? 4s minus 4s in fact, so that we can say minus s plus 4s, that is equal to minus s2. So 3s will be s2, s will be 1/3 of s2 with a negative sign. But as we have explained earlier, s2 is what? s2 is 1/4. So finally we can see s will be minus 1/12. That means initially we have started with this sum 1 plus 2 plus 3 plus 4 and so on. If we carry up to infinity, required sum can be written as minus 1/12. Now obviously this result is very much important in case of string theory, where we can assume that the world is of dimension of 26. But in practical sense, obviously this particular proof seems to be little bit difficult as well as strange, but still it is very important. I hope you can understand the analogy. Obviously I have tried to explain this in a simple way and hope all of you can understand this one. Thank you.